Okay, so with this Varignon's theorem, we can write the equation as 1255. This is equal to minus r into d. Okay, so you can equate these two values. So this minus r into d. So this is equal to 1255.88. Okay. And therefore d is equal to, this is 1255.88, and the resultant value. So resultant is 316.29. Okay, so this distance will be negative because the summation of moment we get as a positive value 1255. So this value will be, okay, so this is equal to 3.97 meter. Okay, and this is negative value minus 3.97 meter. So what is the significance of this negative sign? Because distance, it cannot be negative. So negative means our assumed position of the resultant is, it is wrong. Okay, so we will try to change this position. So this was the point O, and initially we have assumed the resultant like this. Okay, and we assume the distance with respect to point O as a d, which was the perpendicular distance. And by using the Varignon's theorem, we get the value of d, which is minus 3.97. Okay, so the negative sign means actually resultant, it must be on the left side of the point O. So just try to correct the resultant position. So we will show the resultant like this. Okay, and this distance, this is the perpendicular distance. And then you can write here d is equal to 3.97. Okay, so this is the correct position of the resultant with respect to point O. Okay, so this is your r value, and this is the angle, which is the theta. Okay, so I think it is 18 point something. And then you can find out the x distance, which is along this rod, okay, or this pipe. So suppose this is a OA. So by using trigonometry, you can find out the distance x. Okay, so this is your final answer. So just we have corrected the original diagram, that is this diagram. So initially we assume the resultant to be on the right side of the point O. Okay, but we get the distance d as a negative. That means the resultant, it must be on the left side. Okay, so just find out the distance x. So in this triangle, so you can consider this is point O. Take this point as a m, and then this point as a n. Okay, so in the triangle OMN, you can use the trigonometry. So this becomes ON as a hypotenuse, and the OM, it is the known distance, which is 3.97. So you can consider this triangle. This is a 90 degree. This is a hypotenuse, which is the ON, and this is the N. Okay. So here x distance, which is unknown. OM, it is the known distance 3.97, and the angle is known, which is the angle N. Okay, so this angle is 18.43. So use the sine theta. So sine theta is equal to opposite is OM upon the hypotenuse is ON. So OM is 3.97, ON is X, and the sine is 18.43. Okay. So get the value of X, which is 3.97 upon X. Sorry, 3.97 upon sine 18. So it is 12.55. So whenever you replace this original system by the resultant system, then you should place the resultant like this. Okay. So this angle is very small with respect to x-axis. So this is 18.43. This is your resultant. Okay. And this distance from point O, so this is 12.55 meter. Okay, so I hope you have understood this problem. So the steps are same compared to the last problem. Okay, so now note down the next problem. So here we have to replace the force system by a single force and couple system acting at point B. So the given system, it is the general force system. So there are three forces. One is 722, next is 1000, and third is 632 Newton. Okay. So the forces are acting at different point and in the different directions. And we have to replace the system by a single force. So this single force is nothing but the resultant force. Okay, so we have to find out the R value, and then single force and couple system at point B. Okay, that means if you replace this system by new system, then that single force we need to shift at point B. Okay, so just assume the force is in this direction. Right? Okay, so right now we don't know what is the direction. So this is just an assumption. And there has to be one couple. Okay, so this is resultant force and the coupled system. So your final system will be like this. Okay, so we have to find out what is the value of r, direction theta. Okay, then we have to find out the distance d with respect to point B. Okay, and then we will shift that resultant at point B. Okay, so finally we will get the diagram like this. Okay, so here your first step is we have to resolve the forces. After that, write summation fx and summation fy. Then find out the resultant and the quadrant of the resultant. After that, find out the angle theta. Okay, so first step is resolve the forces, but in the diagram, angle is not given. Okay, but some dimensions are given. This is 2 meter, this is 3 meter, and this is 3 meter. Okay, so from this dimension, you can find out the angle. So just observe how to find out the angle. So for 722, so you can see this is the line of action. Okay, this is 2 meter. So this is 2 meter. Okay, we can find out this angle. Okay, so I will assume this angle as a alpha. So alpha